everyone. Good afternoon. Goedemiddag. Welcome you to the TU Delft Library. My name is Vincent Salucci. I'm a program maker here for the Library Learning Center, and thank you for joining us this afternoon. Our subject for this event will be assistive robots and human-robot teams. This is a part of the SHErobots program and exhibition. It's still up. If you haven't had a chance to check it out, I highly suggest you do it afterwards. And it's put on in collaboration with the University of Sydney and New South Wales. And it explores female researchers at the forefront of robotics. Given that we have many experts on this subject at the TU, we have a side program. It's just a lecture series we're calling the SHErobots Cafes. I see you found your ways to the lunch trays, but if you haven't before, please treat yourself. And there are some dietary restrictions provided for. If you stipulated that, I hope that it's still there and that you other people don't take the ones that were meant for the other people. So please try to do that. And but they're all vegetarian, so no worries there. And anyway, we're going to have the schedule for today is that we're going to have two presentations by researchers at the TU Delft, and I'll introduce them shortly. Then I'll have a small discussion with them, and we get them a little bit of conversation going. And then we'll, of course, open it up to the audience for a larger discussion. And I do believe that we also have a guest of honor today in robot form. So we'll be hearing maybe melodies, maybe songs, maybe other things from our special guest. So without further ado, I will introduce our two speakers. The first speaker is Anahita Jamshidnejad, is an assistant professor at the Department of Control and Operations, Delft University of Technology, where she has established her research group on mathematical decision making. She co-founded the AI Man Labs, where the MDM collaborates with the Intelligent Systems Group, which is from the EMCS faculty, on integrating optimization theory and AI approaches for decision-making of artificial agents in teams composed of humans and artificial agents, aka robots. Our second speaker will be Nazli Cila, assistant professor of human agent partnerships at the Faculty of Industrial Design and Engineering. Her research focuses on collaborations with autonomous agents, such as smart products, robots, and AI systems, and their social technical implications. It's a little bit of a tongue twister. She integrates empirical work, e.g. experimentation, future modeling, and prototyping, with philosophical, ethical, and practical issues regarding trust, responsibility, control, and intelligence. Her mission is to create foundational theory on human-agent robots, partnerships, and reveal interactive patterns for meaningful, aesthetic, empowering collaborations with agents. She was gonna say anything? No, I wasn't disturbed. I thought I needed to pass the mic. Okay, well, I think I'm going to turn it over to you and maybe it.
Yeah. Okay, good afternoon, everyone, and welcome to this event of SHErobots. So today we will be presenting about robots in contact and collaboration and interaction with humans, and the factors that play an important role in the success of these interactions. So if I could have the slides on the... Yeah. So my part of presentation is about robots for and with humans. And what I mean by this is that robots that should replace humans when we don't want to do some of the tasks, so they should have full autonomy, and robots when they should be in between us in order to collaborate or interact with us when we need to have them as companions. Okay, so the first topic that I will be talking about is full autonomy of robots. By full autonomy, what I mean is that robots that have to perceive their environment, understand their environment all by themselves without any intervention from humans. they should, after perceiving the environment just like us as humans do, react to the environment. So they have to make decisions that are appropriate and good for the tasks that they have in that environment, and they have to also implement them all by themselves. What you see here is actually a test that we did, a simplified version of a test where a ground robot and a drone that is flying and now is out of the view. These two robots together are sending data to each other, one of them from ground view and one of them from aerial view. And they have to realize how this object is moving that is sometimes obstructed for the view of the ground or the aerial vehicle. So this experiment by itself is showing one example where we want robots autonomously and probably in collaboration with each other, but without any intervention from humans to perceive their environment. The second part is about when these robots come really into the society and they are interacting with us. So that's about human-robot interaction. One of the very important things that matters here is that both the human and the robot should understand each other, because that's what happens between us. If I'm making a conversation with you, I understand you and you understand me so that the interaction can go well. Otherwise, it will fail. And the other factor that is very important is trust. We can only engage in long-term interaction with each other in a meaningful way and collaborate with each other if we have at least some level of trust in each other. Trust for robots in the human is something that, okay, we can just make it perfect in most cases if needed, but trust of the human in the robot is more challenging. And that's a part that we, again, have to consider when we are programming or developing algorithms for robots. And the final thing is that when robots are coming into our lives, we also expect them to show some social capabilities, just like humans do. What is this social behavior? We, in our social interactions, we understand each other, we adapt to our needs. I even personalize my interaction with each of you. After a while, when I get to know each of you, I will personalize my type of interaction, the words that I use, the behavior that I have, more or less to each of you. And that's what we want the robot to be able to do. So it's adaptation and personalization. Another important factor is that we are only okay to accept robots if they respect more or less our norms. By norms, we mean whatever that we accept in the social behavior, norms of behaving in casual or formal situations, if we need respect, if we need them to be fun. So these are context awareness capabilities that these robots should have in human-robot interaction. Okay, what I'm doing is that I look at all these problems from a systems and control theoretic point of view. And what does systems and control theoretic point of view mean? It means that when I have any real-life system, I need two mathematical modules for it. One of them is a model, and one of them is a control system. A model is something that mimics for me what I should expect from this robot. If I give it a particular input, what kind of output I can get from it. So we formulate it in a mathematical way. The control system is a part that will decide what input, if it's given to the system, would provide the desired output that I want from the system. So these two modules are collaborating with each other and will decide what inputs to give to the robot so that the robot moves or talks or interacts with people the way that is needed. What you see here is some physical behavior from the robot, and usually modeling the physical behavior is just based on rules of physics, kinematics, and so on. That's easy. The more complicated part is that when I have to give an input to the robot to get a behavior that is accepted by you as humans. So what I have to model for the robot is what is happening in your brain. It's about your mental state, your needs, and your cognition. So that's also a kind of modeling, not only the physical things that we see. So my presentation will focus on full autonomy for search and rescue robots. because these are robots that should go without supervision of humans into unknown environments and tackle the challenges that are there. And then in the human-robot interaction part, we have two aspects that could also be related to search and rescue. So looking at search and rescue robots, there is a part that they are all by themselves in a building in fire. But they should also interact with firefighters sometimes. They should interact with victims that they find. Therefore, human-robot interaction, even for search and rescue robots, is important. And finally, regarding their social behavior, I would like to show you a few experiments, some movies of the experiments, where we provided these characteristics of a social behavior for robots. So let's see what are search and rescue robots. Our objective of deploying search and rescue robots, which were actually one of the first times that they were used in a large scale, was in September 11. In the incidents, they sent very basic robots just to go in very kind of narrow tunnels that humans would not go and capture some photos. But nowadays, robots are more smart and advanced than that. But what we want nowadays from robots is that they go into the building and they search as much as possible in the shortest time, and they detect the victims. So I am working with a group that I call mathematical decision making. So we would like to do many things from a mathematical point of view. But if you look at the goals that we have, you can see that when I talk about maximization or minimization, I can do pure mathematics. But as soon as I want robots to detect the victims, I need some machine learning. As soon as I want them to deal with uncertainties, whatever mathematics that we do, we need to also bring some elements of AI or artificial intelligence. Why? Because we as humans, when we rely on our heuristics, we are excellent in dealing with uncertainties. We are much smarter than the most advanced robots in going into a building that we don't know anything about and dealing with the unknowns and uncertainties. We want to put that behavior on robots that have to autonomously mimic our behavior. To give you an example, suppose that this red dot is a robot, and it has to move in between these stones without crashing into them. A mathematical approach would create something like this tube and will make sure that the control system of the robot will always steer the robot inside this safe tube. However, this tube, when it's mathematically designed, could be very conservative in the sense that mathematics can only say, okay, I will take the safest place for the robot. This is not always good if you look at the goals that I had, because this means that my robot is not able to search everywhere. It should be super careful. So what if I can make the tube a bit more flexible? Not what pure mathematics will give to me. That's what us as humans do. As we move forward, we adapt, we adjust based on what we perceive. And that's where we would like to have the knowledge of the human on the robot. And again, this is where AI, combined with mathematical decision-making, helps us to have this autonomy in robots. So suppose that I have these autonomous robots. Now I want to use them for search and rescue. People are in a search and rescue environment. We want to save them. But this is really the kind of behavior that more or less we see. Of course, this is exaggerated, but people in panic, they behave strangely. They do not behave, even if they are trained for that situation or they have received some instructions, they do things that could put each other in danger. That's another reason when we send evacuation robots into the buildings that are in disaster. But we have to be able to let the robot understand these people, right? And that's what we do, again, by using mathematics and AI. Humans in disaster will interact with each other and will also think by themselves individually. We do not always expect people to act rationally. Yeah? So one of the things that we do in modeling is that we use, for example, game theory. Game theory is a theory that says how very rational agents interact with each other. If I put that to say how humans interact with each other while evacuating the building, I have a big problem. I'm assuming that they are rational. But we know that, for instance, while we expect a normal human being to run away from fire, still a very, very normal mother would run into the fire to save her baby. So we do not expect that traditional definition of rationality to always hold, because our emotions, our beliefs, our cognition will change our behavior. And that's why, again, such a model combined with a cognitive model that says how the belief, desire, intention, or emotions and would affect our rational behavior will help the robot to understand what to expect from humans. They could be different from my companion robots that will always be rational and will always take distance from fire because they are programmed in that way. So this will help my robot to have an understanding of the humans. This is also important in creating trust, because if you're in a situation that you feel that your life is in danger and you see a robot on your way and the robot says, I'm going to show you the exit, would you follow the robot or would you not? It, to a large extent, depends on your experience with robots. If you have seen a stupid robot before, you have seen robots always failing, probably you will not. But it also depends on the interaction on the spot. So suppose that you see a lot of people are trusting robots and they are really safely evacuating the room. Suppose that you once listen to the robot and go a bit further, and then you see, oops, the robot is really taking you to the fire. So trust is really not something that is static. Trust is something that during the interaction, it evolves and it changes. In other words, it's a dynamic variable. You can even model it with a differential or a difference equation. And that's, again, how one of the characteristics that is completely human-like, like trust, we can make it mathematical for a robot. And in that way, by analyzing this mathematics, we can understand, or the robot can understand, how should I improve the trust of these people in me so that I save them. The last part that I talked to you about in my introduction was the social behavior of the robot, and in particular, the perception of the human, evaluation of the situation. That's very important. Is it a casual situation or a formal situation? Actually, I would like to show you a movie about this. Because I don't have that much control with this one on the movie, I will first explain it. So I will show you a movie of this experiment that we had with the robot. So this robot has been given some cognitive model that, with the use of a mathematical logic, which we call fuzzy logic, we have tried to translate the cognition of the human and the situation for the robot, in the sense that the robot gets some awareness that, okay, if the person needs respect, I have to show respect. If I make a mistake, I have to fix it in one way or another. So it has some awareness of what is an acceptable behavior. What you will see in the movie is something actually funny, because we were recording these movies for another reason. This researcher was putting on this captain hat, and the expectation was that the robot will switch from a casual, friendly interaction into a very formal one, and she would just say, like, hi, sir, and would respect. But what happened is that there is also an image processing. The robot has a camera and has to detect the hat, but it failed. You know, AI fails many times in real time. That neural network that had to do this failed at some point, or the robot did not capture. And you will see that the researcher gets a bit annoyed and says to the robot, okay, well done, but only if you had detected it in time, because he thought that the movie is now destroyed, because we were recording it for that. But the fun thing is that the robot takes a bow, and then she says, I'm sorry. So actually, what we expected from the robot worked properly. It realized that I made a mistake, and it shows if it goes to the movie. Yeah, okay. So this is what you see here. I put only a part of the movie. They were in a casual situation. They were having a friendly conversation. Here, Davide put the hat on. The robot didn't detect it, so he really has to take it to the camera, and he's really a bit pissed off. And then she says also, "Oh, sir." And then he says, "Yeah, only if you could detect it in time." And then that's the reaction of the robot. He says, "It was me. Sorry." And then as the movie goes on, you will also see that at some point, the researcher Davide suggests to the robot, "Now I want to share something more private with you," while he still has the hat on. At this moment, we were actually testing what if we put the robot in a situation that a combination of two situations are there. So about context awareness, I want to tell you something private now. "Okay, David, tell me, sir." So the robot gets a bit confused. There is still the captain cap. She says, "Sir," but she also wants to be friendly, so she calls Davide with his first name, David. That's how the robot calls him. So this is as like basic as it may look, or like funny as it may look. It's important because these are the things that create our social interactions. And we could show that a robot, without pre-programming the exact scenarios, just giving it some awareness, can more or less adapt to the situation and create something that we as humans like. We accept it, right? And this is important for acceptance of robots in our societies. I would like to show you one last movie. Yeah. So here you see a completely different way of interaction. It's one of these drones. I don't think that they are very common for cognitive human-robot interaction. These drones are used, and the battery has been removed now. That's why here it's empty. But these drones are very good for research. They are even, like this is the one that in one of the first slides I showed you that was collecting aerial data because it has its camera. But we don't expect such a thing to have any cognitive interaction with humans, but this is what we did here. So this research is, actually this one is a pilot for a future research where we want this robot to interact with people with autism, because people with autism are very much attracted to such gadgets, like a drone like this. And there is one thing that, one therapy that is called movement therapy that like the therapist should either with very mild music make some movements and the person with autism will follow, but these people may also disengage during the interaction. So the therapist should also follow sometimes when they do something else, they don't follow. And that's what the drone is doing here. If you check the movements of the drone, in real time, the drone is capturing the movements of the person. If it sees that the person is not following my movement, it will follow the person. And if the person is very well following the drone continues. How is it happening? We managed to actually keep people, these are people without autism. So usually you should quickly get bored with such routines. But we managed to have experiments of half an hour, and people were still excited to do it more, because the drone was adapting. Was not only adapting to switching the roles, but also adapting to your pace, to the amplitude of the movements. This by itself is a real-time analysis of what is happening in its environment and a real-time decision-making via what we call a fuzzy logic control to react to it. And this will summarize my presentation with a bit of delay. So I talked to you about the autonomy of the robots. So autonomy is when we do not want to intervene at all. We are not around the robots to tell them what to do and how to adapt. So it's all by themselves to do it. Partially, they may have completely far from human behavior, right? So like they may do some things that we as humans don't do. For example, optimization, our brains don't do that. That's when full autonomy is expected. There is another aspect to robots, and that's when they are brought into our societies. And there we want to see them more social. We are okay with a humanoid like this one to make a mistake and then say, I'm sorry, we like it. But in full autonomy, we don't want that, of course. So based on the goals, based on the tasks, these are different things that we expect from the robots, and all with systems and control theory we are bringing for robots. Thank you for your attention. Now I will give the floor to Nazli.
Right. Hello, everyone. Welcome. We are just switching to my slides, I guess. And meanwhile, my name is Nazli, and I'm an assistant professor at the Industrial Design Engineering faculty. And I'm a really designer, I don't have an engineering background. I am trained as an interaction designer. And so I'm really interested in this design quality. So if these robots are integrated into everyday life, how does it work? What happens, and how do we design them to work in certain ways? And I have a short presentation regarding that. But I don't see any. Is it coming? Thank you. So those are two questions, meta questions that drives my research. So what is required from humans and robots in terms of collaboration qualities? And also, what are the qualities that are relevant for designing these collaborations? And I think we have quite a nice natural, connection with Anahita, because many of the things that you mentioned, you will see coming back into my presentation too. But before doing that, I want to bring us back to the human realm. So really nothing about robots, but I would like to ask you to think of a moment that you collaborated with someone, and it felt good, oh yeah, we worked together very well, a human. It could be something in the context of work, or you bought a present for your mom with your sibling or something. Any kind of collaboration is fine, but can you tell me a couple of qualities? What made it good? No right and wrong answers, but what makes a collaboration good? Yeah?
Clear communication.
Clear communication, yeah. Thank you. Reliable, yeah, exactly, yeah.
Feeling of mutual helping, someone's helping you with no expectation per se, but you're also helping them with no expectation, but it still feels good.
Yeah, so mutual support and really, yeah, exactly. Thank you. Anything else? Yeah? Same expectation, yeah. Thank you, perfect. And one more. Yeah? Ability to, sorry?
To continue the conversation in the same line of thought, or maybe a complementary.
Complementarity and the same line of thought. Yeah, exactly. Thank you so much. Everything that you said will also find themselves in the framework that I will show you. But there is this philosopher called Michael Bradman, and he has this shared cooperative activity framework that he developed for human-human collaboration. And actually, it really involves everything else you're saying, because it's very straightforward. So what he says that, good collaborations have these three qualities. Both parties should be committed to this joint activity. So we are in this together, and we are doing it together. They are mutually responsive towards each other. So if I do something, I know the other party will respond to it, so we will build up on each other. And if something goes wrong, we are committed to give each other support, you are committed to mutual support. So what I did first was to really I did this very big meta review from the human-computer interaction, human-robot interaction fields to understand what are the topics that researchers are dealing with, and try to bring them together under this quality. So I identified if we need to adapt these human-human collaboration qualities to human-robot collaboration, what kind of qualities need to be designed as designers. And in this, I only have 15 or a maximum 20 minutes, so I won't be able to go through them all, but I picked some of them. But for the rest, I'll give a more meta description of what they're about. But if we start with the commitment to the joint activity, it's really about the ground rules of the collaboration. So, what are the moral responsibilities we have each other, and what are the task responsibilities towards each other? So, who is doing what? So, even before starting the collaboration, certain rules should be in place. So here I want to specifically talk about, for example, task delegation. During the COVID time, we have seen many uses of robots, and I think these two were quite successful. The one on the left is like a walk going towards the public spaces and hospitals to spray some like disinfectants, and the other one was checking in with the patients in ICU, and those situations were quite dangerous for people to do. So I think they were quite meaningful uses to delegate to robots. But robots were also used for these purposes too. This one was checking the fever of temperature of the people in the entrance of the buildings. The other one was keeping on reciting the rules of the social distancing, which sounds a bit gimmicky, right? Like it's not using the full potential of being what a social robot could do. So what is typically a good, like a guideline, is that we must always strive for, like, understand how humans can most effectively augment machines and how machines can enhance what humans could do the best. And in that regard, these researchers from the Mark Hassensahl's research group in Germany coined the term robotic superpowers, and I really find it a nice metaphor to think about it. So what are the robots are a lot better than humans to do. And they were studying the context of healthcare robots, and they identified, for example, being void of competitiveness, having endless patience. They are like unconditionally subordinated. They assume responsibility, etc. These are like really the superpowers of robots, and as humans, we are not always very good at achieving this. So we have to find out for the context what are the robotic superpowers, and we try to leverage them. And I think your like search and rescue robots are a wonderful example for this, because they are really dangerous and basically dangerous situations that we should be very we should be delegating to robots. So after every quality, I have some questions maybe to reflect on as robot designers. So we should ask ourselves, like, what is the task that I want my robot to perform? And maybe a promising starting point, a guideline could be, we should strive for augmenting and not replacing the skills of humans while leveraging on the robot's superpowers. So that is maybe the first takeaway. So I am now skipping to the mutual responsiveness, and this is the moment of interaction. So I am across a robot, so our interaction is starting. So what happens there? What needs to be designed? The first one is more about autonomy and control. So how much autonomy I should give to this robot? So what's the autonomy level? And in which moments that I should take away that autonomy, and how much proactivity this robot should be assigned to, when it should intervene, how it should intervene, are very actually interesting design challenges. And the other one is about intelligibility. It's about explainability. If I could, as a human being, understand where the decisions of this robot is coming from. And last one I particularly want to talk about in this context is common ground, which is about knowledge, beliefs, and suppositions two people, in this case, person and robot, believe they share about the activity. So if they have the same understanding about what is happening. And this requires, very simply said than done, but the user must know the robot's status and intentions, and the robot must know the user's status and intentions. But we have seen, like with the captain example, how difficult it is. And there also, sorry, the image quality went very badly, but one example is, again, a robotic exercise companion that the University of Sydney has been designing. This drone is really helping people to reach their running goals and also coach a bit. But of course, the user can also intervene with the decisions of the robots. And they have been showing again and again that the people didn't want to talk to the drones because it was a bit weird in the social running environment outside. So they really were looking for a bit more implicit ways that they could communicate with this robot. So they were really looking into gestures, maybe turn this way, stop kind of gestures, maybe help the robot to understand what this person's intentions are. Another, outside of the, again, verbal commanding way is maybe gaze control is another way to do it. So instead of telling the robot what to do or gesturing, can I just control what I want the robot to do with my eyes? There are different verbal and non-verbal ways. These are only two small examples. But what is important at a principle level, we have to think about how do we establish this common ground between the human and the robot. And we can really enable the robot to read the user's intentions. It could be through the verbal commands, gaze, and gestures. Again, quite an interesting and open design area. Continuing with actually BDI again, so I want to refer to BDI in another context. So, okay, so now I have given very simple examples about how the user could control the robot, but how does the robot could communicate its own intentions and behaviors. And this explainability is, of course, quite a big research area. So I picked only one or two examples. But what has been shown with the verbally communicating robots like also Nao or Pepper, if they needed to explain the rationale behind their decisions, it has been shown that they should really follow the way that humans explain things. So it's coming from the BDI principles, beliefs, desires, and intentions, and at least two of the three should be there. So instead of saying, I did this, or I intend that, they should have a combination. I did X because I intended Y, or I intend to do X because I needed Y. So like two out of these three should be there for people to trust these decisions and also have a pleasant interaction with the robots. This was really like robots mimicking the human communication, but also there are some researchers saying that, but robots are separate entities. They're not humans, so maybe they should have their unique ways of communicating. And in this particular one, the researchers were looking into not like a human-like exactly, but also like still something understandable and communicatable. So they were experimenting with like a not 100% grammatically correct sentences, but still being able to explain what the intention is. So doing sleep 10 seconds, attempting forward, avoiding obstacle, etc. So still using language, but maybe adding this a tiny bit robotic flavor to it. Or another example, which is really not robotics related, but I really like it a lot. These researchers were looking into smart home ecosystems and how the data through all the smart products could be communicated to the users. And we are very much used to seeing these graphs and very quantitative data in front of us. But they were saying, what if we give this data through daily horoscopes? So horoscopes were really meant as something very vague and open, so you can pull and push according to the way that you want to interpret it. So they were really looking into this ambiguous, deliberately ambiguous ways of communicating with the people as a design experiment. And it was also taken very well by the users. So what's the point I try to make it here? So the question that we should ask, how do we explain the intentions and behaviors of robots? So on one side, we can really resort to the psychological mechanisms of how humans explain things. BDI is one example, but there could be other ones, while also considering potential communications means that are unique to robots. So we should also maybe feel free to experiment with other ways to communicate. And very lastly, commitment to mutual support. So if something goes wrong on both sides, how the other party could help towards reaching the shared goal. And two things. So one is that how can, if some human is stuck, how an agent can offer help. So it's about really their studies about how much proactivity the robots should have when they should intervene or if they should intervene. And what I want to talk about here about if agent is stuck, if it makes a mistake, again, in the not able to recognize the captain head, what happened? How could they request this help or admit to the mistakes, apologize? And it has been shown again and again, there are multiple studies that if a robot asks for help, people help them. So it's we have this natural tendency to help the robots. And in this particular one, the robot is quite old, but trying to reach a certain destination in Germany, and it has been asking for help, and people were really getting out of their way to help the robot. So regardless of being these are inanimate entities, we have this natural tendency. So we take this for granted, but how do we build up on it as designers? One example, the same delivery robot. It's not the same robot, but all delivery robot examples I'll show you. So what if they are stuck or someone is blocking their way? In this one, it's a bit like emotional manipulation strategy it uses, but I'll be fired, it says. So you will be empathizing with it and get it out of the way. Another one from Japan, it has these eyes, very expressive eyes, and it has this like, what does it do? That can be made teary in sadness if pedestrians block its way. So it's again all play into this emotional, I think, they are trying to strike that chord in people. So the same intention, but you can see how different ways that it could be communicated. This is about asking for help explicitly. In this one, the researchers were looking into the politeness strategies, like again, borrowing from human-to-human interactions. What kind of strategies work for robots to ask for help? And so in there, like spoiler alert, but they were saying positive politeness works the best. So what they do is that the robots should a bit say something nice about the person and then ask for help, such as you diagnose problems really well. If you teach me to diagnose the copier, it will be very helpful in the future. This kind of strategies, according to their research, would work the best. Another example is that showing that incapabilities. As we, I think, all know, robots fail a lot, or they are not capable to do everything. And in this particular example, the robot, just with gestures, imitates the actions that it's not it wants to do, but it cannot do. So here in this example, trying to rotate a knob. So just by showing that it wants to do it, as a human being, you are more inclined to enter the scene and help the robots. So that's one way to solicit help. And another one, researchers from University of Radboud, I think, they are looking into the confusion gestures. So the robot is comes across a task that's not 100% how to do. So it just scratches his head or just puts his hand on his forehead. People are, again, more inclined to enter the scene and help the robot to just do the task for it, or just be careful to watch closely if the robot is able to do it or not. So gestures of this confusion or hesitation have been shown to really increase the trust a lot in human-robot interactions. So, a question to ask as designers. So what are the most effective means for a robot to request help? And it's very context-specific, so we really have to study the context. But the first thing we could do is we could investigate the factors that influence compliance from humans, so imitating that. Or we can really design robots that display the inherent uncertainty in the task or context. Another way to go. I will leave it here. I won't be able to go through it all, but I'm around. If you have any questions, I'm happy to talk more about. Yeah, thanks. Thank you very much. Yeah. Oh, yeah. Do we come back, or?
I'd like to invite you both up again. We'll have a small conversation before I turn it over to the audience. So thank you again for our presenters. And Nazli, you got to respond a little bit. We paired you. It was a nice pairing because of how connected both of your research were. So you drew a point of some of these connections, but I was curious if, Anahita, if you would like to respond to maybe after Nazli's presentation. Can I put you on the spot?
Yes, sure.
Oh, you have your mic.
Yeah, I do. So I will just...
Yeah, just to some of her connections that you were talking about. You're both working with the BDI and trust and modeling. So
yeah. So actually, I think we are working both with this belief, desire, and intention out of coincidence. This Bratman, the philosopher that you showed, he introduced this concept, the BDI concept. So I think that's one of the things that we are using jointly. And I'm using it in order to generate the trust. As Nazli explained, 2 out of the 3 elements, that's something that actually I learned from your presentation.
And other researchers, yeah.
So 2 out of these 3 elements should be there to gain the trust. In our case, we use this BDI model for full transparency. So this is a model that will tell to the robot how the human will work. And also we put the model sometimes on this robot in order to have the robot behaving like the human, if we want to have a human-like cognitive behavior. I think the other aspects that you talked about was the trust. And I think there, yeah, we again look at it from a mathematical perspective. So we model it in a dynamic way, but I think, Nazli, you look at it in depth from the perspective of like,
Theory a bit, so like,
yeah,
conceptually.
in the theory. So I think Nazli is mainly looking at the causes and reasons, and what we are in my group looking at it is that, okay, these causes are there. How do we model them in a mathematical way, and how do they evolve in time? Not that how they are initiated or what is causing them, but suppose that if it's there, how do we model it in the course of time? Yeah.
I think like this was also a really nice collaboration for me with like looking at the collaboration qualities, but we didn't know each other before this whole event, but throughout these chats we realized how much we have in common. And what I like that my work is quite theoretical, and I just try to bring it down to like examples to the concrete, and I think yours is really based on the making things work and like abstracting, generalizing from them. So I think we meet in a nice sweet spot in that regard. So it was also nice, thanks to you to bring us together, but it was a nice way to reflect on what we are doing, I think.
Absolutely, and I think the applications. Yeah, I don't know. When I first spoke with Anahita when we were preparing this, I was like, "Oh, search and rescue robots! Like this is dramatic and exciting." And then to see how much theory and modeling goes into this before. One of I want to switch the topic a little bit to the subtitle of the SHErobots exhibition and program is Ecologies of Care, and I was curious, how do you see care or the complexities of care within your work, and I'm thinking specifically like sort of this trust and the more psychological goals that you have, maybe you can respond to that, some of the context.
So in my case, I mainly focused on the application of search and rescue. That's what we had promoted initially. But as you saw, I showed you in the slide before the last that we also we work on therapist robots. So actually the robot that you see here, this one is not good for any type of search and rescue tasks. She is not suited for any dangerous situation. I brought two examples. Of course, these are the tiny robots, but do not be surprised that the one in the middle will be something similar to the very basic ones that I told you initially. They were sending them into narrow tunnels in order to bring back photos. So actually the humanoid robot, and even in my group we went one step further by using a drone, are meant to do some psychological service for the person. And that's indeed where I think this element of care comes into the practice. In particular, we consider people with cognitive impairments because of many, many reasons. One of them, Nazli mentioned about like the COVID lockdown. I think that was one of the times that the importance of technology, not only for regular services that we expect, but also for cognitive support of humans, became more and more highlighted, and now we are following up on that. We know that not all people, especially people with special needs, have access to therapists. Not all insurances cover everything. Not all countries have access to all these sciences. That's why we think if we could have technology that provides this support, at least to some level, not only to replace the therapists, but also to help them. It will be very advantageous, and that's where the social behavior, the third element that I explained in my presentation, is very important for this kind of robots. I think also in support of the human staff that are providing care for us in healthcare.
Yeah. And my take on it would be not particularly about the healthcare, but in care, the way that maybe ethicists use. And also ecology is actually quite an important part. And I didn't have time to go through it in this presentation, but my main point is that when a robot enters any kind of scene, everything around this shifts. And so because like the people's behaviors change, but also it has quite like a political and ethical questions around like this, like future of work or like a bias, everything like else, you know. So I always want to study robots, not a technical actor just on its own isolation, but the ecologies that it is embedded in. So that is why about politics or regulations or interactions, everything in different layers plays a role in my research. So ecology is in that sense, and care is more about. I think it's a term that is really associated with I think feministic research, and I am a bit critical of it in the sense that I think it's all about humanistic research. It should be, but care principles such as reciprocity, such as taking responsibility, really showing vulnerability, thinking holistically. So not about the technological artifact per se, but really looking into the whole relationships it creates and changes. I think those are quite important principles that we should always bear in mind if we are designing robots. So we are not just designing the robot, but we are designing the whole ecosystem that needs to be cared for. So that would be my take on it, I think.
Absolutely. That was a brilliant answer. And I think the Australian contingent that we were collaborators for this program in the exhibition would be thrilled to hear how you outlined both the ecologies being operative within your research, and then as well as even the sort of critique about, yes, there's this more humanistic concern, not just a feministic concern. But to that, I'm going to put a little even more pressure on this because I do think that these collaborators would agree with that statement wholeheartedly. But I'm curious if you do see gender operative in your work and how, for both of you.
Do you? Yeah.
In the big picture, I would say no. When we come maybe to that part of the personalization, but I would say that minimizing it and limiting it to the topic of gender would be, it's just a side thing. When we talk about personalization, I think it's about accepting and understanding every individual. It could be, one of them could be gender. Maybe it will, like robots need to have some general knowledge in order to later on scale down and make it more and more personalized. It could be that some general knowledge that is available about genders could be provided to the robot, but to be honest, we never had it as one of the main research challenges, at least not in my research.
Yeah, it's also not particularly about my research. I don't really feel, the way that I practice it, any kind of pressures in that regard, but of course there's research on gendered robotics, like how the bias it brings, or the way that maybe it will be, of course, cliche, but it's a cliche for a reason, like human type of robots are assigned to certain roles versus male. So those are the things I think we should break, especially at the design faculty. We can really play with that, breaking the roles of genders and being more explorative in the ways that robots behave. But I am lucky enough that personally, being female doesn't really provide disadvantage. It doesn't provide advantage, but also doesn't provide advantage, let me put it like that, yeah.
Well, great, yeah, I was just curious because, I think that there's a very, I certainly respect what you're both saying, but it just, even embedded within some of the research, like the pilot's hat, right? How many women do we see wearing those hats? So this is a visual indicator that actually is still embedded with some gender, right?
Indeed, something funny that happened in those experiments. So the researcher that you saw in the movie, he had programmed the robot that the respectful behavior when you see the captain head is to say, "Yes, sir." And we had one participant, she was annoyed by it. She said to the robot, "You should not say yes, sir, to me." So that was something that, so we had not foreseen it. But these are the things that we could consider, but then we have to go further and further to make it even more and more inclusive. Well, I think,
I was curious too, just because in casual conversation you referred to our guest here with the feminine pronoun her, and I said it, of course. And so, when we think about the level of trust and our relationship with robots, right? That somehow, we automatically resort to gender without even thinking about it, right? And so Yeah, that's
This had a particular reason. She's called Madam. So I have to call her she.
And can you tell us a little bit more about Madam? Because maybe some people can talk to her after the discussion
Yeah,
part.
so normally now that she's on, so she's coming from Japan. That's the origin of these robots. She's a sibling of Pepper that was in the slides of Nazli. Normally she should be able to greet with you when she's on, but when you get close to her, you will see that the eyes have lights. When they are blue, it means that she has detected you and she's ready to interact with you. If you ask her, she should normally give information about who she is, where she's coming from, even some things about her sibling, Pepper. She can sing a song. She doesn't have a very good voice, but if you really ask her, she will do that. She can dance, some Tai Chi movements. But these are, of course, the entertaining parts that are coming with the robot. And I think maybe they have some impact to go more in depth in the scientific discussion for accepting the robot at the beginning of any interaction. But all the elements that Nazli and I were talking about are the important ones that help you to stay attached to the robot and continue the interaction in the long run. So you will see a lot of fun, entertaining things from the robot, which is important as the first impression to attract you. But I think the things that we are discussing are mainly the main challenges of human-robot interaction when you want to, in a long term, to have meaningful interaction with the robots. These are the things that matter. Maybe I think at some point that participant was annoyed by the fact that she kept on calling her sir, and maybe that would be another element that I can consider.
Great.
In
Well,
this
I think that's enough for me. I would like to turn it over and see if some of the audience members have questions. Start in the back.
Fascinating presentations. Thank you so much. Just on that last point, how much can Madam or Pepper learn about someone, develop and build up knowledge and record and build knowledge to continue a relationship over the short or medium term? Thanks.
Yeah. Thank you for your question. So whatever function that you see from this robot at the moment, because I have not connected it to any program, is what she comes from the factory. So by herself, she's not able to personalize. But the robot, the version of her that you saw in the movie, she can learn to the level that, of course, we limit the scope in the program. For example, if we have to give some initial knowledge to the robot, for example, what is gender, what is the roles in this institution, what could be the norms. And within the scope that you define for this robot, it can continue to personalize. So you have to give some framework, and inside of that, she can start to learn and personalize. And this is all about which parts in your program are given to the robot and which parts you keep free as the kind of tuning parameters that the robot will work on and will start to learn about. To give it in a different way, she's like a baby that is newborn with a completely blank mind. So you have to provide some context. For example, we are in a library. And what are the rules of the library? These are some things that she has to know. But then, okay, this is a human being. In general, human beings have these cognitive states, needs, beliefs, and desires. And then she can start to learn your needs are different from another person's needs. Your preferences are different. You wouldn't mind if she calls you sir or madam, but another participant would really be annoyed. And then she has to learn not to make that mistake with that participant.
Thank you. So my question is that you discussed that in social care, these robots can be used, but especially in situations such as if elderly people use it, then they might not be willing to adopt this. They might not be willing to have robots helping them. So what's your take on that? How do we deal with this situation?
Nazli, would you like to?
My personal take should be we should make it meaningful for them. So it's not like it shouldn't be the reason that, of course, I don't think you mean that, but they should use it, and how can we make them use it? But I think the need should come a bit from them, and maybe it won't be natural, but if we really show that these robots could make a meaningful impact in their life, whatever the needs they have, I hope that it will emerge more naturally. so we should really study the target group and their needs. And we should also sometimes say, okay, robots might not be the best solution here. So we should be very critical of our work. So not the technology push, but really should come from the other side, I would say. And that's maybe the point of care in a more broader way. So I think we should really achieve it by really understanding who we are designing for or who this robot is for. It's a very open answer, but it's difficult to achieve for sure. Yeah.
Yep.
All right.
And maybe I could add that like there are two aspects to the robot, the physical appearance and the behavior. So what I'm working mostly on is the behavior. That's why we work with this robot, because we have realized it's attractive enough for the majority of people. But of course, there is a lot of research running on which physical aspects of the robot can make it acceptable. Supposing that all those questions have been answered, there is another aspect to it. That's why we talk about personalization. That's why we talk about norm awareness, context awareness. And in such particular care applications, we always provide some initial knowledge from the caregivers, or if the patient is able to provide it. So that's kind of the framework that I said we have to provide some context, and then the robot starts to fine-tune it and make it personalized to you. That kind of rule-based or initial framework should come either from the client, the patient, or their caregivers that know them very well. And these are the kind of tricks that we use in adapting the behavior of the robot for that person to make it acceptable.
Okay, thank you.
We've got three here. Maybe we can...
Hi, I just wanted to ask, could you please expand on what fuzzy logic control entails? Because I don't really know much about it.
Yeah. Okay, thank you very much for the question. So fuzzy logic is actually an extension to the traditional logic. Traditional logic is purely mathematical. Fuzzy logic is a kind of a logic that tries to mimic how we as human beings think. To give you an example, in mathematics we have numbers. 1 is 1, 2 is 2. But we as humans don't work with quantities. We work with qualities, like it's a bit lower, it's higher. We don't give numbers. This has been actually translated into a mathematical logic, which is called fuzzy logic. Based on that, they have also looked at how we as humans make decisions and how do we steer our environment so properly based on these non-quantified perceptions that we have. And that's called fuzzy logic control. So fuzzy logic is the mathematical language that says how we can perceive our environment without really working with exact numbers. And fuzzy logic control says how we use this knowledge to make proper decisions that are very efficient and very high performing.
Right, thank you.
Thank you. Yeah, very interesting presentation, both. Thank you very much. I was wondering how the rise of large language models fit into both of your research.
You would like to first?
Yeah, I have to think about it. Not immediately right now, but I was also like in this human-robot interaction conference 2 weeks ago, and it is really up and coming. It was all the keynotes were about that, and it's very like, it is very hot right now. And it's a good question that you put finger on. I have to also digest a bit, and so I don't have an immediate answer for that. But I will get back to you about that, sorry.
Yeah.
No worries.
In my case, actually, the interactions that you saw between the human and the robot were using one of the existing ones. So where Davide, the researchers, for example, said, if you would have just recognized it or identified it yourself, this is not that we have told to the robot, this statement means that you made a mistake. So it was the processing of this conversation or this speech. The robot associated some, okay, I did something wrong because the grammar, the sentence suggests it, and then it reacts based on the program that we had. So in our case, we are some users of these developments. So they are helping us to focus more on the part of our own research, making use of the available technology.
Okay, thank you.
Thank you for your presentation. I was a bit surprised when you were talking about robots and how they're really good at taking responsibility, and especially in these like socio-economical factors when we see the interaction. I was wondering what would be your take on responsibility when a robot makes a mistake, maybe in a fully autonomous situation or environment?
I think taking responsibility of the mistake I was referring to, in the sense that really, okay, I called you sir, but I shouldn't have, so it's very concrete. But I think maybe you are referring to more like a bigger life-threatening, that maybe engineers or designers are more responsible
Legal
about.
consequences and so on.
Yeah, exactly. And then it becomes the terrain of ethical AI, ethical responsible development. And I'm a really, quite an important part of my work is also about that. What is really ethical decision? What are our responsibilities as designers, engineers in this terrain? And maybe also partially referring to her question about like maybe sometimes robots are not even the best answer. So we should also really look at critically about our work and really try to make a meaningful contribution. And if there's a mistake, more systemic mistake is made, then we should really claim the responsibility. And partially, of course, done is through regulations. But before coming to that, we should also, as being an educator here, teach our students to have this ethical campus within themselves. So ethics shouldn't be a checklist or whose responsibility everyone points fingers to each other, but really something to everyone kind of internalizes and takes responsible decisions. And that is really one of the very big skills, I think, as like a future robot designers should really have quite a strong opinion about. Yeah, I don't know what you would like to say?
Yeah, I totally agree. I think there you are the expert, but it also brings something related to the search and rescue robot. So you're very right that like mistakes there are not something like, okay, she made a mistake and she apologizes and we even laugh. And I think there we are mainly users of the knowledge that you're developing, and we provide it to the robots because it's very important for a robot, for example, when it faces two people, one of them bleeding, one of them a pregnant woman, for example. And then it's in a very difficult situation. I think the challenge of what decision to make, which one to first support is an ethical question. And I agree that it's something that is still going on, and we have to see, because even as humans, I think it's an open question in such dilemmas what we do. Of course, for robots, it's even more important. But these are, again, like the kind of frameworks that we provide as a kind of rule base for robots based on the information that we get from colleagues that are mainly working on.
I think that's really why interdisciplinary working is like, or human-robot interaction is a very interdisciplinary field. Like we really need engineers, designers, ethicists, policymakers, all of them really working hand in hand to make these futures possible. Because the challenges are quite complex. Not one discipline could solve them. Yeah.
Indeed.
Thank you for an insightful answer.
Thank you.
Anyone else? We might have time for one or two more. Oh, a second?
I'm wondering how far do you think we are from fully autonomous search and rescue robots?
Yeah, that's a good question. It very much depends. So when we come to the part about searching of an environment, I think we are quite advanced. So whenever it's about data analysis and there are not that many humans involved, we can do it more or less okay. But as soon as it comes to the part about human-robot interaction, there are all these challenges that are still running. But actually what we are thinking about, or what at least I think would be the ideal situation, is that we are not trying to totally replace search and rescue staff with robots. On the contrary, we are going to let humans to use their specialities and the capabilities that we can probably never, ever in the near future, if ever possible, provide for the robots. We want to provide a safe place for humans to use that. We know that in search and rescue, the very first stages, that is about like mapping the environment, knowing what is happening, they are the dangerous parts. And we have seen cases where we lose, for example, firefighters just in those stages. So the idea is that in a smart way, we can share the tasks, and we have robots that in some parts, they can fully autonomously perform, but in other parts, they delegate the task back to the humans. So it's mainly mainly, we are not thinking about that very kind of science fictional world where everything is taken over by robots. And that's why we continue doing research on human-robot interaction. So that's the ideal picture of search and rescue robotics.
Okay, thank you. Interesting your take on the future, that we're not fully replacing everyone, but more augmenting our own abilities.
Indeed, yeah.
Thank you.
Thank you for your presentation. I have a quick question. I just wonder, do they have any lifetime based on their memory constraints, or what else?
You mean the robots?
The robots, yeah, the small robots.
Yeah, indeed, that's one of the important things, that when you deploy a robot and it's out of access, supposing that we don't have charging stations, which actually I think is one of the main problems during search and rescue, is the kind of the power that the robot has, and this power is actually shared between different things, computations that the robot does on board, movements, whatever the actuators do. And that's why I said one of the goals of search and rescue is optimization. And one of the factors that we optimize is how much power is being used by the robot. But there are practical solutions for that. You can assume that you deploy some robots to first locate some charging stations, for example, and then the more valuable, computationally demanding robots will be deployed. But it's an important point for search and rescue to also minimize or find a trade-off between the tasks that are being performed and the power that they need.
Thank you very much.
I was curious, maybe one last one from me, and we'll conclude. But we're talking about, there's the search and robot, the assistive robots, but then this teamwork robots. And this question was a bit inspired by this young man's question, which I thought was a great one. His last one as well. But is it, how far along, we've had some scenarios in which, the rescue one and stuff, but like true teamwork robots, like I'm curious about this, like, yeah, I mean, of course we're now using ChatGPT as part of our teamwork and desktop assistants, but in these more like physical, robust robots, like what other scenarios, like we saw the thermometer one and the spraying antiseptic one, but I'm curious just how far along some of these are, or if there's any inspiring examples that you have to share with us that you've come across in your research.
Yes, so next to search and rescue robotics, robots, I think, are being used in tasks that are very exhaustive for humans, or they are repetitive, they are being used. I think even like the use of, for example, drones in not only capturing data, but also to participate in control in future smart cities in a collaborative way. It's also one of the applications that robots are being used. Search and rescue is a part of it, but as I said, evacuation robots are completely a different scenario. Like they have to interact more like socially with the humans. I think in industry, we have different types of robots, so you may always think about a robot with a physical appearance, but like a robotic arm is also a robot, right? And sometimes there are physical interactions. These robots should also be safe if they are around humans. So we have different types of robots, from flying robots to ground robots, wheeled robots, legged robots, like these dog-shaped robots. And they are being used also in different tasks. And also in each of these particular applications, I think we have one robot for each task. For example, as I said, this robot is very good for making a meaningful conversation with you. The legged robot is the only one that can go up from the stairs. You can never expect this small wheeled robot to move there. Even this wheeled robot that I brought for you, it fails in the cyber zoo of TU Delft, which has these fake grasses. It fails to move because of the long grasses. So there, for example, you may need a different type of robot or more robust wheels. And that's, I think, yeah, so that's why we have this variety of the robots and the variety of the applications.
Yeah, I also would like to say it's very context specific. Like you said, in certain like manufacturing contexts, we are quite far ahead with human-robot teaming, I think. Maybe search and rescue is up and coming, but healthcare has been also robust, I think, years. And I work a lot with dairy farming industry, and dairy robots are also used quite like a nice, really very nice collaborations between farmers, cows, and robots. So you can really see robots bring something meaningful to that context, because like there are some a lot of repetitive tasks that farmers need to do. So robots could really take away that burden. So farmers have been quite happy about this collaboration, because then they could put their time in more meaningful things for really about the well-being of the cows, or really attending to their needs in a more different way. Or it gave them quite a nice, much more time that they could go to their swimming lessons of their children or something. So it's kind of, those are the moments I think this kind of working together with robots really made a difference. Yeah, so for some context, it's already happening, and there's already quite a big potential. Some of them are more up and coming. It's quite fascinating. We can leave it like that, maybe.
I think in addition, we can also name entertainment.
Entertainment also.
You see nowadays these drones that are even dancing with professional dancers, and also education. If you do a search on YouTube with Now Robot, NA also, this Now Robot has already been used in education with very young children. And of course, they are attracted to the robot, so if they hear something from the robot, they are more happy to accept it than if I or the teacher says it to them. So that's another promising field for the robots.
Perfect. Thank you so much. Please, let's give Nazla and Anahita another round of applause. I'll get the graphic up. And I would like to invite the audience to stay a little bit and try to converse with our guest here.
Yeah. Can we make her sing?
And of course,
I will try.
yeah, we can see if she, if you can make her sing, we'll give her the mic real quick. But I also wanted to.
I don't promise, but I will try.
I also wanted to invite you to the next SHErobots Cafe, which will be later on in April. So by then you'll be certainly hungry for more sandwiches and SHErobots events, and we'll be discussing robot bubbles and robot driving in detail. So
can you sing a song?
Please join us then.
I'm not a very good singer, but if you want.
I think.
That's it.
Yeah, I totally agree. She's not a good singer.
She's got a little melody though. All right, thank you all. Have a wonderful rest of your days.